Alrighty, so first let's refresh by talking about a problem that we solved yesterday with factoring. So we did a problem like this yesterday. How many terms does that polynomial have? 3. There's 3 terms, x squared, 4x, and 5, all separated by addition and subtraction. So that polynomial has 3 terms. When it has 3 terms and an x squared, it's the form ax squared plus bx plus c. That's a quadratic, right? What is a for this polynomial? A is the number in front of x squared. So what's in front of x squared for this one? A is 1, right? Those are the kind that we did yesterday, right? There is no number in front of this, so that means there's an invisible 1 there, okay? Those are pretty easy. We did these yesterday. When we did those, we look for 2 numbers, then multiply together to get -5, and add together to get 4. See if you can figure out what those numbers are and finish the factoring. This is from yesterday. So we need 2 numbers that multiply together to get -5. What are the only 2 numbers that multiply together to get 5? 1 and 5. So those are your only options here, 1 and 5. We know they multiply together to get a negative. If they multiply together to get a negative, what's true about one of your numbers? 1 has to be negative. If you're going to multiply 2 numbers together and you get a negative, 1 has to be negative. So it could be the 5 or it could be the 1. If I make the 5 negative, will I add those together to get +4? No, it'll be -4, right? So that's not the right combo. We want the 1 to be negative because we need to add them together to get 4. So remember from yesterday, we can jump straight to our factoring. We know the first 2 have to be x and x because they'll multiply together to get x squared. And then we'll have a -1 and a +5. So this is what we did yesterday, right? Factoring that when a was equal to 1. Yesterday we talked about quite a few different types of factoring. We kind of went over a lot of the main ones. Today we're going to talk about what we do when a is not 1, because it's not quite as simple when a is not 1, okay? But we did a lot of types of factoring yesterday. So if that was a lot and you had a hard time recalling all the factoring, or you knew that it was a struggle in Algebra 2, you're going to have to stay on top of that, okay? I'm going to put the homework again out from last night, so pick that up, use the videos. We do have a quiz on Thursday over all the factoring and a test on Friday, okay? So make sure you keep up with it if it was something you struggled with. So today we're going to talk about now, what about if a is not 1? So a is not 1 or a is greater than 1. So for example here, this polynomial still has 3 terms, but what's a there? What is a for this polynomial? 3, right? So it's not 1. So it's not going to be as easy as what we just did, okay? This is probably the most difficult type of factoring. There are lots of different ways you can do this. Some people still use the X method to do this. If you like that method, you're welcome to use that method. I don't know all the ins and outs of how it works because I never learned it, but you can use that. I'm going to teach method 1. This is what I will use in class. There's another interesting method called the slide and divide method. I'll explain what that one is. You could try that one if you like that one. And then there's also just kind of guessing and checking and seeing what works. If you're really good with mental math, you might like that method. Okay, so we're going to talk about a few different ways, and then we'll practice a few with method 1. If you want to try one of the other methods, I do on the homework tonight, like I do them both with slide and divide and method 1, so you can kind of see which one makes the most sense to you. Okay, so we'll start with method 1. So basically, the problem here is this 3 in the front, right? It changes everything. So we have to involve it. So the first thing we're going to do is multiply that 3 by the 2. And 3 times 2 is 6. So we're actually going to start this problem in a very similar way to we started the last one. We're still going to look for two numbers that multiply together. But instead of multiplying together to get 2, we now have to involve that 3, right? So they're going to multiply together to get 6 now. Okay, so we have to involve that 3 in the front. So two numbers that multiply together to get 6, they're still going to add together to get your middle number. So this is step 2. We're going to find two numbers that multiply together to get that number you got by multiplying the front times the back, and two numbers that add together to get the middle. So go ahead and think about what numbers you think that would be. Two numbers that multiply together to get 6 and add together to get 7. Don't jump into the factoring yet because you can't jump straight to the factoring. But think about what you think those two numbers are and write them down. So two numbers that multiply together to get 6 are 2 and 3, and 1 and 6. If we add 2 and 3 together, do we get 7? No. So is that going to work? No. So 1 and 6 are our numbers, right? Those multiply together to get 6 and add together to get 7. But you cannot jump straight into the factoring like we did here, okay? It doesn't work like that. So now what you're going to do is you're going to, in step 3, you're going to take those two middle numbers, or those two numbers, and you're going to replace the middle term, 7x, with those two numbers. So you're going to copy down the 3x squared, keep that the same. But we're going to replace 7x with 6x and 1x, because 6x plus 1x is the same thing as 7x, right? So we're not changing the problem. We're just replacing 7x with those two numbers we found. 6x and 1x, and then copy down your 2 at the end. So we just replaced that middle term. We didn't change it, right? It's still 7x because 6x plus 1x is 7x, right? We just put them in there. This is the weirdest part, is that part. Now how many terms does that polynomial have? 4. Yesterday, did we factor things with 4 terms? Yeah, that was our factor by grouping. Remember when we drew the line down the middle? So now you're just going to finish this by factoring by grouping. So let's refresh on how we do that. Draw the dotted line in the middle. Look for your common factor on the left-hand side. What common factor do 6 and 3 have? 3. 6 and 3 are both divisible by 3. Is there also an x in common with those two terms on the left? Yeah. So our greatest common factor that we're going to pull out there is 3x. Then in parentheses, we'll write what we have left. So when I divide this by 3, the 3 goes away. It was an x squared, so when I pull out 1x, what am I left with? Another x here. Because we had 2 to start, we pulled out 1. There's another one left. The 3 was pulled out. We divided by 3. When I look at the 6x, I first deal with the 3. So we factored out 3. That means we divided by 3. So 6 divided by 3 is what? What's 6 divided by 3? 2. And then we pulled out the x. So is there going to be an x left here? No, we pulled out the x, right? So that's just looking for your greatest common factor. On the right-hand side, do 1 and 2 have a common factor? Yeah, 1. Everything has a common factor of 1, right? Any two numbers you pick are always divisible by 1. Is there anything else besides 1? No, right? Do they have an x in common? No. So technically, every possible term out there is going to have a GCF of 1, right? Usually, we don't pay attention to that, but when you're factoring by grouping, it will help you to think if there is no greatest common factor, pull out a 1. And remember, we pull out the sign, whatever sign is with that number in the front, we pull that out with our greatest common factor. So this one will be plus 1 since there's no greatest common factor. And when we divide each of those by 1, it's not going to change anything. So we'll still be left with x plus 2. Because you're dividing by 1. And remember, when you do factor by grouping, we want these to match. Do they match here? Yes, so that's going to be one of our factors, x plus 2. And then we write in parentheses what's left when we pull out that x plus 2. So what's left over here on the left when we pull out x plus 2? 3x. And what's left over here on the right when I pull out x plus 2? Plus 1. And that's why it's helpful to write that plus 1 in the front, is so that you're reminded when you're factoring something out, you should never be left with 0. It'll always be 1 because you're dividing. And then we have factored our polynomial to start with. And so if you notice, the reason why our other method didn't work, because these two terms aren't going to just be x and x anymore, right? When there's a 3x squared in the front, these are going to have to multiply to be 3x. And that's what makes this a little bit more tricky. Okay? So that's the method I'm going to use whenever I do it in class. Okay? The only thing I would say, if you have a really hard time with the factoring by grouping, you might like the slide and divide method better. Okay? So I'm going to show you slide and divide method. If you just feel like it's confusing, then never remember it again, move on, and you'll be good to go. Okay? But I want to at least show you something else you could use. So just a note, whenever you use slide and divide, you would have to factor out the GCF first. It's really in your best interest to always do that. The other method will work even if you don't do that. This method, you would have to make sure you factor out a GCF first. But that doesn't happen too often. In some ways, this method feels very similar to the other one. Okay? So again, I'm going to show you this. If you don't like it, that's fine. Put it away. Never think about it again. If you kind of like it and you want to see it more, I do have a homework video posted with both methods on it. Okay? So the first thing we're going to do with the slide and divide method is you're going to slide first. So we're still going to multiply that 3 with the 2, but we're actually going to slide it over there. So we're going to move it from the x squared and slide it over with the 2 to multiply them together. Now you have a polynomial where a is 1, so you can factor this polynomial. So that's step 2. You just want to factor this polynomial like we did yesterday. So you're going to look for two numbers that multiply together to get 6 and add together to get 7, because this one has a is 1 now because we moved it over. And we already found those numbers earlier were 6 and 1, so this would factor into x plus 6, x plus 1. But what you do have to remember with the slide and divide method is you can't stop here, because that's not the answer. We found the answer earlier, and that's not the answer. So once you slide and factor, now comes the dividing part. So because you slid that 3 over at the beginning, you have to divide each of the numbers by that number. Okay? So you're going to divide the 6 by that number you slid over, and the 1 by that number you slid over. So this, we did slide, now we're dividing. That's why it's called slide and divide. Then you reduce any fractions, so you simplify those fractions. 6 divided by 3 is 2, so this first one will become x plus 2. 1 divided by 3 does not simplify, so that's going to stay x plus 1/3. So we slid, we divided, and then the very last step is to, if you have any fractions, you're going to take the denominator and slide it in front of the x just for that term. So here we'll take the 3 that's in the denominator and slide it in front of the x for that term. So the x plus 2 will stay the same, but we'll slide that denominator in front of that x for that term. And we end up with the exact same answer that we got up here. So that's the slide and divide method. It has just as many steps, okay? So it has quite a few steps in it, but there is no factor by grouping. So if you really have a hard time with factoring by grouping, that might be a case where you like the slide and divide method. If you're okay with the same steps over and over again, and you don't like factor by grouping. If you understand factor by grouping, what we did up there is not much different than what we did yesterday. As long as this one you factor out the GCF first. If it has a greatest common factor, that's the only time that it doesn't work. You would have to factor it out and then do slide and divide for the rest. Okay, any questions? Again, if you felt like that was confusing, then put it out of your head and don't worry about slide and divide method. If it seemed like something might be helpful and you still need some more practice, the homework video has that method in it as well. All right, the last option is guessing and checking. So this method is only going to be if you can like kind of think about the multiplication in your head and do a lot of mental math in your head, you might like this method. So this method is literally just saying, okay, we have our 3x squared plus 7x plus 2. We know it needs to factor into 2 parentheses, okay? And if you're pretty good at doing a lot of, basically you're kind of going to undo the multiplication in your head and see what works and just try out a few things. So you would start by saying, okay, I know these two have to multiply together to get 3x squared. So one of them has to be 3x and one of them has to be x. Now, this does get more complicated with higher numbers because like if that was 6x squared, it could be 6x and 1x, or it could be 2x and 3x. So bigger numbers, there's a lot more guessing and checking that you have to do. But with smaller numbers, it can be pretty easy if you're good at the mental math. And then you would say, okay, I know the last two numbers have to multiply together to get 2. So that's 1 and 2, right? Those are the only options. Now you have to figure out where they go because when you multiply it all out, you need the middle to become 7x. And that's the guessing and checking part, okay? So for example, if I put the plus 2 here and the plus 1 here, if I think about what would happen when I multiplied out, I would multiply these together to get 2x, and these would multiply together to get 3x, add those together, and I only get 5x. So that would not work. That would not be a good combo. And that's why it's called guess and check. But if you switch them, and you multiply, put the 1 and the 2 here, multiply the 1x together, you get 1x. 2 and 3x, so you'll get 6x, put those together, and that will become your 7x. So that would be your work. So it's literally just guessing and checking and undoing the multiplication. Some of you are really good at the seeing all that in your head, and so this might be more efficient than doing method 1. My only recommendation is that you do know how to do method 1 in case those numbers get really big and you just can't work through all the combinations and see what works. Okay? Any questions? If you had no idea what I was talking about, don't worry about it. That's fine. Okay? It's just for people that can kind of think through all that stuff very easily. Okay, so now let's do a couple practice together. I'm going to use method 1 for each of these. If you want to try slide and divide or guess and check, feel free, but I'm going to use method 1 because that's what I'm going to stick to in the classroom. So for method 1, we start by multiplying 3 and 2 together. We got to, since there's a 2 in the front, we got to multiply it by 3. So we're going to do 2 times 3, which is 6. And you're still going to look for 2 numbers that multiply together to get a number. It's just 6 now, right? You can't look for 2 numbers that multiply together to get just 3 because of that 2 in the front. So now we multiply that 2 in the front by 6. We're looking for 2 numbers that multiply together to get 6 and add together to get -7. So still adding together to get the middle number, but you just have to multiply that 2 and that 3 together to figure out what you want them to multiply together. So try to figure out what those numbers are. So numbers that multiply together to get 6 are 2 and 3 and 6 and 1. We know that we're multiplying 2 numbers together to get a positive, but adding them together to get a negative. How's that possible? What does that tell you about your numbers? They're both negative, right? Because if you're going to multiply together to get a positive, they're either both positive or both negative, but we're adding them together to get a negative. So if I make -2 and -3, those are going to add together to get -5, not -7. So that's out. But if I make the 6 and the 1 both negative, those will add together to be -7. So our numbers are -6 and -1. Now, the biggest thing you have to remember is not to jump straight to factoring here, because that's what we usually do with those numbers. But because the 2 in the front, we can't jump straight to factoring. So we copy down our polynomial. The first term we leave the same. The middle term, the -7x, we replace with -6 and -1. So remember, it's -6x minus 1x. And that's allowed because that is -7x if you put those together. And then you keep the +3 the same. So you're replacing that middle term with those two numbers. You just have to put the x with it. It does not matter what order you put it in. If you switch the order, you'll get the same answer. Your work might look a little different on the way, but you'll get the same answer. Then we have 4 terms, so we do our factor by grouping. So factor out your common factor on the left and factor out your common factor on the right. On the left, 6 and 2 have a common factor of 2. There's an x squared and an x, so we can also pull out a common factor of x. The first term has an x squared in it, so I'll be left with an x when I pull out 2x. And then 6x has only one x in it, so it won't have an x in it, but 6 divided by 2 is 3, so this will be -3 when we pull out 2x. On the right-hand side, do these have a common factor? Those guys have a common factor? No. So when they don't have a common factor, you're just going to pull out 1, because everything has a common factor of 1. But if you remember, when there's a symbol in front of this number at the beginning, I told you to pull that number out with your greatest common factor. So we're going to pull out a -1 as our GCF here, because the only common factor is 1, and there's a negative sitting in front of that. So when I pull that out, this will just become x. But what's going to happen to that +3 when I pull out a -1? It's going to become -3 because we're doing 3 divided by -1, which is good. We want that to be -3 because remember, these have to match, right? Once you have the matching, you see x minus 3 is one of your factors, and then you look for what's left. So you say over here, I'll have a 2x left when I pull out x minus 3. And on the right, I'll have a -1 left when I pull out x minus 3. And so that is what you should end up with as your final answer. Any questions on number 1? If you switch the -1 and the -x, you'll get the same answer. Your factors inside will just be 2x minus 1 instead of x minus 3. All right, I'd like you to try the second one. If you try this one, you should end up with, I know some of you have already tried it already. You should end up with 2x plus 3 times 2x plus 1. There's lots of extra practice on the back if you would like to use it, and there are answers to the back.